Hi, this is Drew with Multispectral Systems. I'm going to spend the next several minutes going through how to process RedEdge Pancro data in Metashape, and then we'll finish by taking a look at some of the outputs in QGIS. The data set that I'm going to process is a field across from my parents' farm place in Iowa. It's it's interesting because there's a stream bed, there's a creek that runs through the middle of the data set. So it's got some agricultural land, it's got some fallow ground, there's a few vehicles in it, there's a house, and then there's a creek. So some nice characteristics to take a look at. So the first thing we're going to do in Metashape is we will import the um, the images. So if we go up to workflow, you can add individual photos or you can just add a whole folder of images. I'm going to add the folder of images. Um, so the folder is right here. So if I open this up, I can see the 1 through 6 TIFF images from the RedEdge-P. You can see the sizes, 3.2 megabytes and then 10.1 megabytes for each. So I'm just going to grab that whole folder, open it up. Metashape's going to import it. And this is a multi-camera system, so I'm going to select multi-camera system. And if I click model up here, it's going to show me where all the images are located. So if I right click my mouse, I can move the image around. If I select the trackball, I can move this around to look at where the images were captured. So you can see that I had it in timer mode, which is why there's images being captured as the drone rises to the height where it's going to fly the mission. If you want, you can get rid of those images. A lot of times it's good to clean up the data set a little bit before you start processing, so you're not processing more images than you have to. You can speed up the processing time. So right now I've got the little arrow selected. If I click the rectangle, it'll let me grab these images that I don't want. I can right click, I can remove the images, remove 12 images, yes. Um, and then if I go back to the arrow, I can select the trackball again. And you can get like pretty nitpicky about this if you want. I'd say it's best to try to eliminate as many images as you can, because like I said before, it's going to clean up or it's going to speed up the processing time. This is like a pretty clean data set as is, so I probably don't need to do this, but just for the sake of demonstration, I'll do it. So we can get rid of these guys, remove, remove. I don't think I want to remove that one because I think that's my calibration image. So I'm going to enable those. Oop, enable. I could get rid of this one if I wanted to, I guess. But the more particular about this, like I said, the benefit is not processing stuff that you don't need to. So Metashape can run faster. So you can do a little pre-process cleanup using those tools. I think this is let's get rid of these guys too. All right, that looks pretty good. So once you're satisfied with the the data set. The next step is to set the primary channel to panchromatic. So if I go to Tools, I go to Set Primary Channel. They're all labeled, so I'm going to select channel 3, which is the panchro. I'll apply, then hit OK. And then if we want to radiometrically calibrate the data, we go back to Tools, Calibrate Reflectance. I'll hit Locate Panels. Metashape will look through the data set and try to find the images with the calibrated reflectance panel located, where the calibrated reflectance panel is located. Click No. And for some reason, some of these don't have the full reflectance. If I click on a couple of these, I think I found that one of them does have. Yeah, this one's pretty complete. I'll just put 0.47 for the near IR. They're all about the same. And then I'll click Use Reflectance Panel. Okay. So calibration is done. And then the next step is aligning the photos. So if I go to Workflow, click Align Photos, and we can just leave all of the default parameters the same. Hit OK. It's going to ask me to name the project, so I'm going to do pasture 2 since I already did pasture, and I'll hit save. And it's going to run through aligning the photos. So this is going to take a little bit of time. Okay, so align photos is complete. And you can see how the images are really dark. If we go up to tools, we can set brightness, hit estimate, and apply. Then it'll brighten up the images so you can see what the images look like. Not really necessary to do that at this point, but you can do that. Next step is go back to workflow, and we're going to build point cloud. And we'll leave the parameters as is. Okay, once the point cloud's created, we can go to the next step, which you could just jump right to build DEM, but I like to build the model because I think it looks cool. That's about the only justification I can come up with for doing that. So source data is point cloud, surface type, arbitrary. Yeah, this looks good. And this is basically warning me that building the model using the point cloud is going to be more intensive, and using the depth map is probably sufficient. But I've run this through using the point cloud before, and it looks pretty good. So I'm just going to continue anyways. Okay, the model's been created, so now we can move our trackball a little bit and see what the model looks like. Pretty nice. And now the next step is to create the DEM, which is actually a digital surface model, not a DEM. Should go pretty quick. Okay, DEM is generated. We can go over here and take a look at it. There's a DEM. Looks pretty good. And then last step is creating the orthomosaic. We'll use DEM as the surface. You could use the model if you want, but we'll use the DEM. Okay, ortho's created. We can take a look at it here. Um, Everything's going to look grayscale in the image because, well, first of all, the primary image is the pan crow because we set that initially, and then even if we were to look at the spectral bands at red, green, blue, red edge, and near infrared, it also looked grayscale just because um, they're all the just pixel values that you need to that you can use to colorize if wanted, but everything is going to be grayscale. So the ortho looks good as well. Really nice spatial resolution. You can see there's some deer damage over here. Deer got into the corn. Kind of fun detail about this data set. You can see my car parked here where I flew the drone. Um, so that gives you an idea of the spatial resolution as well. There's a corn head. Oop, got a little too close. Corn head used for picking corn on the combine. And yeah, that's it when it comes to processing the data. Now, if you want to export it, you can right click on the data set and export. Um, Export the DEM, all that good stuff. But if we want to pan sharpen the data, so what we're looking at right now is the panchromatic band, but the other 5 layers of this ortho are not at this 4.24 centimeters per pixel. They're probably more like 7, I think, 7.7, close to 8 centimeters per pixel. So if we go to tools, down to orthomosaic, maybe pan sharpen ortho, and Metashape has this nice straightforward workflow where you select the low resolution images, which would not include the pancro, and then the high resolution ortho, which would be the pancro. So we'll just deselect pancro on one side, select it on the other side. This says clip result to high resolution ortho. This means that if the pancro data is slightly smaller than the, the multispectral data, then it's going to clip the ortho down to just the pancro. So I'm going to do that so it looks nice and tidy when it's done. And that's it. Now you got the ortho pan sharpened over here right below just the regular ortho that's non-pan sharpened. And to see the results, I processed this data earlier and brought it into QGIS. And let me just deselect the DEM. And here we go. This is the colorized RGB composite of the from the RedEdge-P. And if you want to look at the DEM, the DSM, you can do that too. So I have that loaded in here as well. And I think I've got it pared down to certain values. I think I just wanted to look at the creek, so you can't see some of the values that are out of that range. But if you wanted to see those values, you could go to properties, and I think up here 210 to 225, so we could raise that up to 230, and apply, and then we'd see more details in the data. And then if I go to the pan sharpened ortho, I think this is pan sharpened, and then this is non-pan sharpened. Let's see, maybe this is non-pan sharpened. Yeah, you can see just a little bit of difference in detail. There's something going on that's causing the pan sharpen to look a little weird, but you can see more details of the shingles on this house on the pan sharpened data versus the non-pan sharpened. If you wanted to create a false color composite using this data, we could click on one of the layers, go to properties. Right now I've got, right now I actually have it incorrectly selected because band 3 is pan, band 4 is red. So if I change it to 421 and apply, it's going to make it color. But if I wanted to make like a false color composite, I could do like red edge, which would be 5, red, which would be 4, and then green, which would be 2. And just to make sure I've got the right values listed on min and max, I can go to histogram and zoom in on what I've got for values. Let's see. So it looks like band 4 goes out to maybe 10,000. Actually, we're band 5. Band 5 goes out to maybe 15,000. So let's change band 5 to 0 to 15,000. Band 4, that looks pretty good. That's going to be captured 0 to 10,000 pretty well. And then band 2, yeah, that'll be fine too. So then if I hit apply, it's going to give me a false color composite that looks kind of cool. So you can mix and match those bands any way you want to try to come up with an interesting false color composite. I found that sometimes if you get the right false color composite, it'll make different species stand out that maybe weren't as clear in the true color RGB. So hopefully this was useful, and if you have any questions, feel free to reach out at multispectralsystems.com. Thanks.